Well, good morning, everyone, and thank you for joining us today. My name is Troy McDermott, and I'll be giving today's 20 minutes of tech webinar from CEC. Today's topic will be how can Wi-Fi 6 improve the wireless experience? So knowing your time is valuable, I'm going to try and pack as much information into these 20 minutes as possible. So I'm kind of going out on a limb and taking a guess at what are, some of the questions you might have. So these are kind of the questions that I'm looking to answer today. First one, who am I and why should you listen to me about any of this stuff? Number two, what is Wi-Fi 6? Number three, how is it different from whatever version of Wi-Fi I have now? And number four, like, why should you care? Is this really that big a deal or not? So those are the four questions where I'm, planning on covering. I would much rather than take a guess at what questions you guys want to hear, I would rather know what questions you have. So Zoom has a text chat question and answer system. Feel free to submit any channel or any questions into that chat channel that you have, and I'll make sure and work that information in, or if I don't have a spot that I'm not already covering it, I'll just stop and answer it. I would much rather know this is valuable by giving you the information you want than just kind of taking some guesses at it. So with that being said, I don't see any questions just yet, but coming in, but I will jump into it. So real quick, I won't waste a lot of your time on this. Who am I? My name is Troy McDermott. I'm a network solutions architect with CEC. I've been with CEC for almost 20 years now. I've always worked at CEC in the networking side of the world. Wireless, routers, switches, firewalls. That's pretty much the only thing I know, the only thing I'm good at. So that being said, I'm really excited to talk about it. Probably it's not a lot of fun to talk about at parties, but if you got questions, I'll gladly speak about wireless and networking and until you're sick of me. So feel free to reach out, give me a call, send me an email, contact your CEC account manager, and we can set up a time to speak. And I can, rather than just telling you the general stuff about Wi-Fi 6, I can get into the specifics about how it affects you and how it might be different than what you have now. So again, feel free to reach out anytime. So what is Wi-Fi 6? Well, it is another name for the 802.11ax wireless Ethernet draft standard. 802.11ax doesn't really roll off the tongue, and it's kind of hard to remember that 802.11ax is newer than 802.11ac, which was newer than 802.11n, and pretty much all the alphabet soup runs together, and it's kind of hard to keep track of what is this equipment compared to something else. So Wi-Fi 6 is just a much easier to remember name for the current wireless standard. Now it's a draft standard, which means it's not 100% finalized, which historically, when the standard gets finalized, that's when they stop working on it and start on the next one. Usually most of the standard is figured out years before it is finalized. And so that's why we've been able to have devices that started shipping 2 years ago for a standard that hasn't been finalized yet. We've seen that in the past with 802.11ac, both waves 1 and 2, and with 802.11n. So it's likely to be finalized in September of 2020. The important thing to remember about Wi-Fi 6 is that it focuses on efficiency rather than raw speed. Up till this point, we've been trying to go faster and faster, and then with Wi-Fi 6, I think we're going to see the biggest usable increase in efficiency rather than just raw speed. So how is it different? I'm going to have to give a short history lesson on 802.11 wireless networking through the years. So of course, going back to 802.11, the very first wireless Ethernet standard, released in 1997, 2 megabits of throughput, which at the time was amazing. I remember when this stuff came out and we first got our hands on it, it was just blown away. Like, how can I do this without a cable? Then, coming 802.11b, which is really where I started, working on it quite a bit. Back in the 1900s, as my kids like to say, we started working on that. And again, it was fast. It was nowhere near as fast as the wired Ethernet at the time. Back then we would have had 100 megabit switching. So an 11 megabit standard, which, again, the numbers I've listed here are theoretical maximum throughput. And to try and keep it comparable, I listed all of them for 20 megahertz channels. And one way that 802.11n and AC got faster is we just started making the channels much wider and we started bonding them together. That's awesome, and that adds to more throughput, but it doesn't really, it's not a technical achievement because that using that spectrum comes at a cost. So to try and keep it comparable here, I've got everything listed using 20 megahertz channels. And again, a disclaimer, this is the theoretical maximum. You never get the theoretical maximum. A good safe number is you can assume you're going to get between a quarter to a third of the published standard. So I remember in the 11 meg 802.11b days, yeah, we were thrilled if we saw 3 or 4. That was, you know, you might see 5 in a perfect scenario, 1 transmitter, 1 receiver, nothing else on the network. But again, when that came out, that was amazing. Then 802.11a and G came along in 2003, and that did a couple things. One is it added the 5 gigahertz to the existing 2.4. So again, that gave us some additional spectrum, some more channels. Really at that stage, that's when Wi-Fi went from, you know, 2 people in a giant empty gymnasium with no background interference to we started having more people come to the party, more transmitters, more client devices, and we started to run into problems where we're having some interference. People are talking at the same time, and it's hard for us to differentiate. So A came along and basically made that room a lot bigger. Now the people can talk and not be talking over the top of each other. And an AC came along, and really what we got there was better modulation. We figured out how to get more information into the same amount of time. Rather than speaking slowly, we started speaking more quickly, and then, you know, all the way up to AC, we started basically talking like auctioneers, which is great. If everybody can understand that fast speaking and can speak that fast, you get this throughput. Now, it's always important to remember that you have this lag where you kind of have to wait for the client devices to catch up. So if I put in a brand new 802.11 AC network in 2013, all of my APs can speak at auctioneer speed. It doesn't do me a lot of good if none of my client devices can understand that fast speaking. So there's always kind of this constant chicken and egg where my client devices need to get updated, my wireless equipment gets updated, my client devices catch up, you know, I upgrade again. So that's kind of another thing to keep in mind, and I'll kind of address that as we go here. So basically, you know, I'm showing over the years, things got faster. That's great. Really what's going on now, though, is we're seeing some cool stuff in 802.11ax that's not just faster, but now I can figure out how to have more conversations at the same time. I can get more information exchange between parties without having to just speak more quickly. So there's 4 big differences between 802.11ax, Wi-Fi 6, and the previous versions. OFDMA, which again is another alphabet soup acronym that rolls off the tongue. That stands for Orthogonal Frequency Division Multiple Access, and we'll cover that a little bit more in depth in, you know, how that in the real world, how that affects us. Another thing we've added is multi-user MIMO in both downlink and uplink. MIMO is multiple in, multiple out. And that was kind of the start of AC figuring out how to have multiple conversations at the same time. But in the past, we only had it in the downlink direction. We didn't have it in the uplink direction. 802.11ax adds it in the uplink direction, which is going to be good. Then we'll get into BSS coloring, and this is not so much an efficiency. We're figuring out how to have multiple conversations, but we're figuring out a way to minimize interference between transmissions we don't care about. And that's actually going to be a big one, and it addresses a problem that we've been fighting for a long time in wireless, is where we've got 2 access points in the same channel. They're both transmitting at the same time, and it's hard to understand who we should be listening to. Another one that is not so big, again, on throughput or efficiency, target wait time, is a power saving technique that is going to help a lot of the low power devices, IoT devices, basically schedule when they need to use their battery to listen or transmit. They're going to be able to do that more efficiently as well. So again, not so much efficient on the throughput side of things, but efficient in the overall user experience. So I don't see any questions yet. I was kind of hoping to get at least one in there from somebody that has something specific they want to see, but I'll give you guys a little bit to get warmed up here. So we'll start talking about OFDMA rather than try and explain all the orthogonal frequency division. Multiplexing is the previous version. So basically, before we had Wi-Fi 6, we were using OFDM, and that's a multiplexing, that's a modulation scheme that goes back to 802.11a and G back in 2003. So it's been around for a long time. The new part here is the multiple access. And what that's allowing us to do is we can have simultaneous conversations with different clients in a way that we couldn't do it before. So a good way of explaining it here is I've got this graphic here, and you can see, the x-axis is time, the y-axis is frequency. On the left is OFDM, and that's what we've been using since 2003. And that basically, one of the ways we allowed to get more information through is we broke up this 20 megahertz band into subcarriers. The best way I can think of it, explain that is rather than one person talking, imagine you've got an entire vocal choir. I've got the sopranos at one end, I've got the bass at another end, and in between I've got a whole bunch of people whose voices are at different pitches. And basically it allows each one of them to be, say we're trying to transmit a book, and I've got the ability to listen to multiple people, in these different subcarriers. I've got every member of the choir is reading a different page of the book at the same time. Well, that's awesome. I can get a ton of that book transmitted in a short amount of time now, but it only works for one person. Say I've got a bunch of people and they all want their book read to them. I can really only do one at a time. What OFDMA adds is the multiple access. Now, basically, I've got and a lot of this comes down to processing power. As all the silicon chips get faster, smaller, more efficient, I can put smarter chips into my access points, into my wireless clients. Now I've got a choir that's smart enough that I can have different members of the choir singing to different client devices. And so now instead of wrapping up the whole choir talking to one client, I can say, okay, the lower sections are going to speak to this client, the higher sections are going to speak to this one. I can break it up, a bunch of different ways. And so that's really increased the efficiency. And, they've got the little diagram at the bottom there with the semi trucks with, basically I can send one transmission out with a bunch of usable information for a bunch of different clients. Cuts down on latency, it increases the efficiency. Really a huge thing there for OFDMA. So I'm pretty excited about that. Any questions on OFDMA? I know that's a hugely complex topic that I squeezed down into 2 slides and a mediocre drawing. So if there's any questions on that, I totally understand. Feel free to let me know. Okay, we'll get into, another feature is the multi-user MIMO on Uplink. And Uplink is the key thing that's different here, but it's worth reviewing what the multi-user MIMO is. It's basically another method for allowing multiple conversations, and it did exist previously in AC, and we even had basic MIMO in N. And what it's going on there, it's kind of hard to explain that because it's really using the exact same frequencies. So I've still got my choir, I'm still broken up into subcarriers, but imagine that I can sing in 2 different languages simultaneously. And so I've got one client that's listening for transmissions in Portuguese, and I got another client that's listening for transmissions in Russian. Both of those clients can hear their individual language, even though I'm transmitting them at the same time. Basically, your mind has the ability to kind of filter out that language that doesn't make any sense to you, and that language is kind of an analogy for the spatial streams that MIMO uses. So we've kind of always had this capability to send out, simultaneous conversations in 2 different languages. What we've gained now is the clients can do that back to us. So I can now, it used to have to stop the whole conversation and only let one client talk at a time. Now I can have multiple clients transmitting in different languages and I can hear both of them. So when you combine this with the ability to have the subcarriers, now I've greatly increased the number of conversations I can have all at the same time. So one feature kind of feeds into another one. It's two different ways of solving the same problem. We do it at the same time. In theory, things are 4 times better. Okay, we'll get into BSS coloring. We've always had a problem with co-channel interference. Let's say I've got 2 access points on my network, and they happen to be on the same channel. Now, we've got a lot of channels to choose from, so we try and make sure we don't have that happening. We don't want channel 36 AP right down the hall from another channel 36 AP. We'll move that one up to 40 or 44 or whatever. But you run into, conference centers, stadiums, really, really high density deployments. We just don't have a way of getting around the fact that we've got 2 people speaking on the same frequency. So what this does is, imagine we do have, we're in a conference room with, 15,000 people, and we're all trying to have conversations with our teams. Really what this adds is just kind of a little identifier at the beginning of a transmission that tells your team that you want to talk to them. So rather than everybody waiting every time they hear somebody say something and listening to hear what they're saying, imagine your radio is shouting out, "Blue team, I want you to do this." Well, if you hear another radio shout out, "Red team, I want you to do this," you can stop listening as soon as you hear them say "red team." From that point on, you only need to listen to "blue team" and then the instructions. So that's going to be a really good feature, because like I said, historically, if we heard anyone talking at all, everyone stopped talking that was within earshot and had to listen to them, and that takes up time. Now, this is going to help, but it's not going to eliminate that problem, because it doesn't really apply when the nearby signal is extremely strong. So if I've got someone from the red team and they're sitting next to me and they're yelling at drill sergeant volume levels, it doesn't do me any good to say, "Oh, red team, that's not me. I don't have to listen to that." If they're shouting in my ear, I'm not going to hear anything from the blue team, whether I try to or not. So again, it's not a silver bullet. It doesn't eliminate the problem, but it is going to help quite a bit. So another one here, target wait time. Again, this is not a throughput efficiency. It's more of an overall device usefulness efficiency. Rather than, right now, everybody that has a wireless device, if it's wireless, it probably isn't plugged into the wall. It doesn't provide a lot of benefit to have a wireless device with a cord. Battery life is always an issue. So if we can have our device go to sleep for a little bit and not be constantly listening, that's great. So historically, devices would go to sleep, but they'd have to wake up every time the wireless network beaconed, which is fairly often in the view of the world from a battery-powered device. What we're getting now is the access point and the client can negotiate a scheduled time for that particular device to wake up. The AP knows, well, rather than knowing that they're going to be listening every beacon, I'm not going to hear from them every, how many 6 periods of time. I want to schedule that time there. This is something that would have helped me in Mr. Resch's English class, because I used to fall asleep at the wrong time. If he would have been so gracious to say, "Troy, we're going to talk about a book you didn't read for 10 minutes, and then we're going to talk about something that's going to be interesting to you," I could have gladly just taken a nap for 10 minutes. As it worked out, we didn't have targeted wait time in my English class. Things didn't work out so well for me there. I had to stay awake the whole time and listen. Again, great from his point of view, but it didn't help me with my power savings. So here's a little drawing that kind of shows there, we basically got Troy in English class and someone else in English class. And since we're interested in different things, we're going to wake up at different times, and we're going to basically, our batteries are going to get saved a little bit. So this is, again, not a throughput efficiency, just an overall, device usefulness efficiency. So I don't have any questions yet. I was hoping to get some by now, but I'll keep going. So this is kind of on a related note. This isn't a feature of Wi-Fi 6, but if you're thinking about Wi-Fi 6, this is definitely something to think about. In the past, the wired network has always generally moved a lot faster than the wireless and had been upgraded more often than the wireless. That has kind of flipped the last few years, and now we're really getting to the point where, years ago, everyone was excited to move to gigabit Ethernet, and once they got there, it's like, well, I don't have a compelling reason to move beyond that. You know, there's been some people upgraded because they needed additional PoE, maybe they needed additional uplink speed back to the wiring closet, but the average gigabit Ethernet port wasn't getting utilized to 100%. Wi-Fi 6 802.11ax is going to be the first standard that will really push beyond that. You are now in the realm where you can have an access point, and if it's fairly well used on Wi-Fi 6, you could max out that gigabit Ethernet connection. I won't dive too much into the new multi-gigabit standard, but rest assured that if you're planning on Wi-Fi 6 as an upgrade, you definitely want to be planning your switch upgrades in accordance with that. It's not going to be a requirement to go to Wi-Fi 6, but you're definitely going to want to plan on doing it soon to take maximum advantage of the Wi-Fi 6 stuff. So at the end of the day, why should you care? Again, we talked about all these great features, but again, they don't really kick in until the client devices are out there. The client devices are out there. They're showing up, especially if you're in a position where you have some control, you know, like elementary schools, they make their purchases of their client devices. They know when they're going to have that. If you know your client devices are coming with Wi-Fi 6 this year or even next year, you definitely don't want to wait, you know, another 5 years to upgrade your wireless. You want to take advantage of those client devices as much as possible. I mean, as I'm sitting here right now, I've got an Apple iPhone 11 that came out, I don't know, a year ago or so, and that's 802.11ax, and it's connected to an 802.11ax access point here in the office. So another point that I'll make is the Wi-Fi 6 access points have recently become very affordable. Now, they've been shipping for a year, even 2 years in some cases. Companies come out with their flagship access point. It's got all the bells and whistles. It can be usually their flagship product is the most expensive. What we're seeing now is the access points have been released that are the ones you would afford if you were going to put 20 of them in a building and not just one. So it's always great when the brand new stuff comes out and that's got a really high density conference room or a cafeteria or gymnasium or, you know, an area that is high density. That's great, but when it really makes sense to me is when all of a sudden the price comes out on kind of that middle ground AP, and that comes out Wi-Fi 6 compatible. That's a really good time to jump on it. And those access points have been out for a while now. And yeah, it's affordable. So overall, it's going to provide a better experience. I did have 2 questions come in. I appreciate those. Are there range benefits to Wi-Fi 6? And this is always a tough one because if you look at the theoretical wireless world, we're not transmitting at a higher power level. We don't have any revolutionary new antenna technology. And those are the 2 things that usually define range. How loud can I yell and how well can the person I'm yelling at hear me? The reality is, though, as we figure out better schemes of modulation, I can speak more quickly at a lower signal level. And so now a signal level that previously would have been too low for me to understand, I'm getting clearer modulation, more sophisticated end devices. So in the end, that does translate to some range benefits. It's not going to be significant. We still are running into, it's been a couple of years now where range hasn't been the defining, you know, I remember, I'll go back 20 years ago, range was the main concern. How can we get this signal pushed more farther out? And we really don't have that now. Really what we're worried about now is density. I don't want this signal to propagate too many rooms down because I'm going to run into that problem that BSS coloring is trying to solve. I've got too many people that can hear my transmission. I'm tying up the airtime. You know, we've solved that through a lot of channels and things like that. So range, we will get some benefit out of it, but it's still, that's probably not the problem we see most people running into. Another question is what kind of latency will we expect? I can tell you the latency is definitely better, and I'll go back and show you why. The OFDMA is really what's solving the latency problem. Is previously, if I was client B, I had to wait until client A was done getting this initial transmission on the left. Now on the right, instead of being third in line, I can get part of that second time slice transmission. So again, maybe I don't have a lot of throughput that I need. Maybe I just need a really quick response. OFDMA, because I can talk to multiple users at the same time, that's going to cut down on the latency because, you know, I don't have to wait as many time slices now to get that transmission. I had another question. Does Wi-Fi 6 improve mesh routers or decrease the need for mesh routing? Mesh routing, or kind of, you know, a wireless backhaul, it won't affect that too much, I don't think. Generally, we see mesh installed when it's too challenging to install a cable to every access point. Outdoor is a good example. I'm maybe putting them on, you know, street lights, things like that. Mesh is really solving a problem that just comes from not having a backhaul. Where it will make mesh have better performance is the inherent problem with mesh is I have to transmit and retransmit. I'm cutting down on the amount of time I can talk to my clients because I have to talk to the uplink. In theory, any improvement to modulation or throughput or efficiency is going to help there. Again, mesh is one of those things that it is always going to be a big performance degradation over having a dedicated cable to every radio. But yeah, I would say it's safe to say that Wi-Fi 6 will increase it just through the need, or just through the availability of better modulation and better efficiency. So thanks again for those questions. I really appreciate it. Feel free to send me any other ones here. Otherwise, I'll get back to, you know, I'll just throw up my contact info here, and feel free to contact me with any questions about this. Like I said, not a lot of fun at parties, but I love to talk about wireless stuff. So if you've got wireless questions, you're wondering specifically, hey, Troy, I've got this, you know, I've got 802.11n here, I've got 802.11ac here. You know, ideally you'd have the budget to just swap out your wireless network every time a new standard came out. We know that's not the reality. Ideally, we can help you say, okay, here is where you're going to see the most bang for your buck. I would definitely upgrade it here. Here, no, you've got some years left in this one. I wouldn't worry too much about that. Those are the kind of conversations that I have every day that I love to have. So yeah, I would greatly appreciate anyone that wants to reach out and ask me any questions. Yeah, that would be great. So with that, I don't see any other questions. We'll kind of wrap it up here, but like I said, feel free to contact me anytime, like day or night. Like I said, this is the only thing I'm good at, so I love to talk about it. Love to hear from you. If nothing else, thanks again for your time. I really appreciate it. As usual, I talked a little bit too much about wireless, and we went over a little bit, but I appreciate it. Thank you very much.